For this video walkthrough, we'll start with the effective security rules for the virtual machine that I'll be using for the demo. We have this SSH rule that allows any IP to connect over port 22 to the host. This is attached to the network interface. And then we have our standard outbound rules, standard inbound rules that are just, that you can't remove. So really the only custom rule here is that SSH rule that allows inbound, which is a pretty standard rule. And so I'm going to connect. Now, obviously this is just me connecting over SSH, but it could be any attacker connecting to a virtual machine inside of Azure over any protocol. I'm assuming it would work for any protocol, for sure SSH, which is a common way of connecting and setting up command and control channels. This is inbound. We'll look at outbound later and also show you how a traditional Fortinet firewall handles this correctly. Now, in AWS, if you compare this to AWS, they have a couple ways of handling it because they have a similar connection tracking issue, but they have documented ways of handling it. One of them adding a network ACL, which doesn't work for intra-subnet traffic, but it works for inter-subnet traffic. And then there's another more complicated way of solving the issue. But in Azure, there's no way of breaking this established connection. So I'm connected to my Azure VM now. We'll just run date command to show I'm connected, and we'll keep doing that as we try to adjust these rules to deny access. And we'll do it a variety of ways. The thing that blows me away the most is that when you add a security group to the subnet, which doesn't exist right now, that is deny all, right? So it has a rule set that denies all access. It still doesn't break the existing connection. So I would understand if you had some sort of connection tracking table that it was referencing before it looked at the rules, and if it's found in the table, it allows the connection to continue. But having that still apply when you apply a network security group to a subnet just seems like a huge vulnerability to me. Even without that, though, it's still an issue, right? Because incident responders are going to be of the assumption I add in deny rules to my policy with the right priority, it should kill this connection, and it does not, which allows an attacker to maintain connections with your virtual machines even after you've taken steps to contain, which to me seems like a vulnerability. This is not a support issue, right? Support's, not going to be able to tell me. I mean, I've tried every single way of killing this connection. If it's that hard, then there's no way support can help me with this. But I will not have the ability to do any sort of incident response with network security groups. I'd have to take some drastic measure like removing the public IP, disassociating the network interface or whatever, so that it no longer can connect publicly. Which that does work. So it is an option, but it is a pretty poor workaround, and most people are going to feel like this is going to work, and it doesn't. So let me show you what I mean. All right. So the effective security group rules are these. We're going to go back to our networking here so that we can adjust these rules. We are connected. We've already established that connection. I'm going to add in an inbound port rule that's going to deny access. We'll start with just the SSH service. So deny any connection over SSH. This is going to mirror the other rule, but we'll put it at a lower priority. Deny lowest priority. Deny SSH. I'm going to add this. And wait for the rules to update here. All right, it looks like it's updated here, but I'm just going to go into effective security rules just to make sure. And I have tested this many times and waited a very large amount of time in some cases, and still it does not block the connection. All right, so deny any SSH inbound has been added now right above the SSH rule, and can still run commands, still connected to the server. All right, so let's just block all traffic, full deny rule, see if that does anything. Just add it as 110, but this is block everything essentially. I guess I should wait to make sure that that gets added. And is effective as well. All right, we now have the all denies. Let's make sure it shows up in the effective security rules. All right, it does. And still connected. Now I cannot connect again to this instance. So it's blocked new connections, but it hasn't gotten rid of existing connections. And I'll just show you. I'll try to connect here. And let me... But it just hangs here. It'll eventually time out, but it takes a long time. It is denied for new connections, but existing established connections, if there is an existing command and control channel that's inbound, it won't work. And like I said, we'll look at outbound later. But there's the same issue with outbound. All right, so that is the inbound, adding the denies. There is some... So what I tried to do was mimic some of the techniques that you use in AWS to get rid of these. But before we move on to that, I'm going to attach a deny all to the subnet. So let me do that. Let me go to security groups here. And I'll show you the deny all subnet security group first so you can see the rules, which is basically deny everything inbound, deny everything outbound. All right, so now I will go back to my virtual machine, make sure that I'm going to the right subnet, which is the subnet called default inside of this virtual network. And I am going to deny all to the subnet, save that. All right, now that that's saved, we're going to wait for it to show up under effective security group rules. Here's the connection timed out for the new connection. All right, that's still not showing up yet. We'll wait. Try again. All right, so deny all, it is now showing up. However, can still use this established connection. So it doesn't work applying it the subnet even after the fact, which should be, if you have a connection tracking table, that should be a completely separate connection tracking table. I mean, this is very strange behavior for a firewall. All right, so now I'm going to go ahead and remove the subnet one so that we don't get confused later on. And as I said previously, I've waited extremely long time just in case it was some sort of timing issue before, and this connection never goes away no matter what rules I have in place. All right, so that is completed. We'll go back to networking here. And I'm going to go ahead and remove these denies as well so that I can show you the technique that I thought would work that doesn't work. All right, those have been removed. Let's just confirm with going to the effective security rules. Still there. All right, let's try it again. Okay, now those are gone. Back to the original connection. I'm actually, just to be really thorough, gonna drop this connection now, right? Because we went through the first use case. So I'm gonna drop it and then I'm gonna reconnect again. All right, reconnected. Now, the next technique is trying to mimic one of the ways that you can solve this inside of AWS. The reason that I'm going through this is I was going to give a talk on connection tracking and containment in the cloud. As I got into trying to figure out how to do containment using your network security group rules, I found that there really was no way. So I thought it would be interesting to make sure everybody knew how to do containment in the cloud, which led me to do some research here and find this issue. Okay, the way you do it in AWS, if you want to get rid of tracked connections, is you add allow all rules to both inbound and outbound, which converts it from a tracked connection to an untracked connection. And then you remove the other SSH rule that we have in here, and then you finally remove the allow alls. which gets you back to the rules that would deny all inbound. I think the outbound still has an allow, but the deny inbound should be sufficient to block it, and I can't remove the outbound denial. Wait, here's the denial. I can't remove this allow internet outbound. That is a rule that I don't have access to. So, but I can also, let's see, no, I don't know if it'll let me detach. No, yeah, I have to have at least one security group, or maybe I can detach it. I think I've, if it's available, I've tried that. Trying to remember because I've done this for different cloud providers. Okay, so I'm going to add my inbound security rule. We'll add this to anywhere. We're going to be an allow. We'll make this 110, which is going to be below everything else, right? So allow any inbound. And while we're waiting for that one, we'll also add it here. Okay, any allow outbound. Even though we already have essentially the allow any, I guess internet, but we'll allow it from anywhere. Okay, we have our inbound, we have our outbound rules. Let's make sure that those are effective before we start removing rules. All right, those are added in and effective. So now we'll go back, and what I'm going to do is remove this SSH rule, which was the one we used to initially create the connection. And it wouldn't be surprising that the connection is still available right now because we haven't removed the other inbound rule yet. So yeah, still active. Just wanted to show that before I remove this other rule. Do it one more time just because that rule hadn't totally deleted yet. I guess we'll look at the effective again just to be thorough. All right, that inbound rule is gone now. Okay, now let's remove the inbound rule. Once that's gone, there shouldn't be any inbound connectivity allowed from the outside world because of the configuration of this security group on the NIC. Still there, so we'll wait. Just make sure that it's gone from here. Okay, it is gone from here. We'll check it again just to make sure it's gone. Okay, that is finally gone, but still connected. So again, if this was a command and control channel, it would still be connected. And this shouldn't matter, but we'll go ahead and remove that outbound rule. Really, the inbound rules are the only ones that matter for this use case. All right, it's gone from here. We'll look at the effective security rules now. And I understand we're not doing any explicit denies here. We can add those at the end, but we already did that in the previous example. Right, and this is a deny right here that should be triggered because this is internet facing. And it's not a load balancer or from the virtual network. Got to wait for this to update. Go back and take a look again. Okay, that's gone now. Still connected. Last but not least, we'll add those denies back in and show that it still does not block. And then we'll look at outbound connectivity. All right. Star deny 100. I'm going to add just a SSH1 too, specific SSH1. Just for good measure. I mean, it shouldn't matter. The any should catch it. And we could do deny on the outbound as well, but I mean, it is inbound traffic, so. That one should not matter. Looks like it still hasn't taken effect yet. Okay, those show up now and still have a connection to the host. So that's all inbound. Now let me do some outbound. Let's see here. I need to do. All right, connected over into AWS. This would be if there's some sort of outbound outbound connection, right? So from this machine, I'm connected outbound. This would be an outbound command and control channel. Here's what we're simulating here. Now, technically, this should be allowed because there is an outbound rule that allows it. All internet outbound. This one here to the internet. Now, the question I have now, is this going to be a tracked one, or we're going to have to go back and make it a tracked one by adding in a specific SSH rule here. But since this is denied inbound, it should be a tracked connection because it's only allowed outbound. Everything inbound is denied. Now, I don't know if the tracking connections is the actual problem here or if it's something else, but it's definitely some sort of issue. It's not intuitive behavior for a firewall. All right. I don't know why I removed those, but it doesn't really matter. I guess I can add them back in. I was just trying to clean things up here. This should be denied still because it's an external connection inbound, but inbound shouldn't matter. All right, so outbound, we can try and deny the connection. We'll start with just the SSH first this time. But really I've tried it both ways multiple times. So we'll start with just the SSH, deny outbound. Still connected. But these rules may not have updated yet. Here's updated here. Let's go over to effective rules. Hasn't shown up yet. I'll have to wait. Okay, now it shows up. Still connected. And we're still leveraging that inbound connection. Even though we shouldn't be able to connect inbound, we are still connected over that channel, which is a separate connection from this one. So there's no tie between those. You know, at least there shouldn't be. And so now we've added that specific rule. I'll add a blanket deny all rule as well. Let me go back here. Wait for that to propagate. Still hasn't propagated. All right, now it's there. So essentially I could have dozens of inbound and dozens of outbound connections from this virtual machine. If they're established before the security group rules are modified to disallow those connections, they remain established. The last thing I'll do is do the subnet again, the subnet deny all rule or deny all security group. Make sure those are effective. All right, those are effective and still connected. Okay, the last thing that I want to show on this video is how a real firewall handles this. It's just fairly straightforward, but in able to do that, I'm going to have to make it so that I can connect to this again because you know, I can't establish a new connection once these deny rules are in place. It's just the established connections that aren't broken. All right, so let me remove this from the subnet so that I can connect into this instance again to show you how my local firewall will handle the changes. All right, I've removed the subnet one. Now I've got to go back and modify this one to allow SSH. I'll delete these. Actually, it doesn't matter if I delete these. I'll leave that one in there because it's just an inbound rule I need. All right, SSH, allow, just so that I can make a connection. I could whitelist it to my IP here. Go ahead and do that. Let me just grab my IP. Or I just do that. Okay, so for my IP address, I'm going to allow SSH. Go ahead and add that. In the meantime, no matter what we do, these are unaffected. Well, now I have a rule in there that allows it, but it's been available this whole time. Okay, so now I should be able to establish a new connection. There's my new connection, and this is going to finally break the old connection as well. So I'm connected to the same server, and then what I need to do here is go to my firewall. Let me get connected to that. All right, this is a fairly straightforward policy setup. I allow connectivity to the internet. It is inspected or whatever, but I am able to connect. There's no inbound rules from my work network, from the internet to my work network, but there is a rule that allows outbound to the internet, which is why I'm able to connect. That connection is tracked because I'm not allowing any inbound traffic. It has to be tracked in order for it to allow the replies, right? Which is just the function of a stateful firewall. Insert an empty policy above. I'm gonna change the name here. Let me just go into this. I'm gonna add a destination. Of a single IP for Azure, and we can do a blanket rule for SSH here in a second, but specific IP address. And we'll go ahead and deny any traffic to that address. Enable that policy. And go ahead and, well, before we do that, let me show you that I can list the contents here and get the date. And now I'm going to add this policy. It's before my main policy that allows traffic, and I can no longer do anything here. Eventually this will time out, but it does take a long time for that to happen. That connection is now blocked. This is expected behavior. This is what you would expect to happen. Sometimes if I delete this fast enough, it'll allow me to reconnect here. Let's see if it does. If not, we'll just establish a new connection so I can show with a blanket SSH deny, or just a blanket deny of everything. Yeah, it's still broken from that block. All right, so let's create a new connection. Same server. Now that I've removed that rule, I should be able to connect to it again. Yep, reconnected. We're gonna insert empty policy above, and just to make it very similar to what we did in Azure, I'm just going to say deny all, and just deny everything. Enable the policy. I guess I didn't show you what I could do before, but now that that denies in there, there's nothing I can do. It's disconnected, just like this one is. So those are both disconnected now. Yeah, so I don't know why Azure is behaving the way it is, but it doesn't allow our incident response teams to contain their assets without taking drastic measures. Like I said, you can go in and disassociate the public IP from the NIC, and that works, right? Then the connection is broken, but that's a pretty drastic measure. Obviously, you could try and connect to the instance and do something to kill the connections there, but that damages some of your forensic capabilities. So hopefully this walkthrough helped.